Everybody, this is Anthony Santosh, Assistant Professor of Chemistry in St. Joseph College of Arts and Science. I am handling physical chemistry. Let us discuss one topic in physical chemistry. Next, we will go and see what is the energy. Okay, energy makes change possible. You can see some diagrams here. It is shown as a light, fire, and battery, and one cycling fellow, and some bigger current transforming posts. Okay, so energy, the ability to do work, as we have seen already, energy makes change possible. Energy makes change possible. Scientifically, we can say energy is the ability to do work. Energy is the ability to do work. It is measured in joules. The unit is joule, just like work. Work also having the same same unit, and energy also is having same unit. There are multiple different kinds of energy. It is simply given here. We will see something more in the next slides. So that is light energy, heat energy, chemical energy, kinetic energy, electrical energy. So these are all different kinds of energies given in this slide. What are all the forms of energy? As I told you in the last slide, we will be seeing so many forms of energy. Energy can be kinetic and potential. Energy can be kinetic and potential energy. It can be, we can see this as a classification also. First, we could see what are all kinetic energy. Energy of movement. It is energy of movement. Kinetic energy can be said the energy of movement. Energy comes from the moving of the materials, like that. First one is here thermal energy. Energy of moving particles. We can say this as heat. Energy of moving particles. Then next, mechanical energy. Mechanical energy, energy of objects in motion. Energy of objects in motion, movement. Electrical energy, next electrical energy, energy of particles moving through a wire. So movement of electrons, we simply know that. Next, magnetic energy, energy causing push or pull. Energy causing push or pull. Okay, next type of energy that is in this classification, potential energy. This is stored energy, just like we can simply get it as a stored energy, that is which is present in the battery. Chemical energy, first one is chemical energy, energy stored in food, fuel. Elastic energy, energy stored in objects that are stretched. Next, nuclear energy, energy stored in center of particles. Next, gravitational energy, energy stored in an object when it is above the earth's surface or when it is felt. Gravitational energy is felt by the materials because earth acts as a magnet, so it attracts, so it is present there itself. So there are we experience energy in different ways here. So here we have another types of energy which cannot be simply categorized as potential or kinetic, or we cannot neglect it is not kinetic, it is not potential, like that. One is sound energy, form of energy when we can hear, and light energy, the form of energy of our eyes can detect. Okay, so these are all forms of energy. Next, renewable energy. This is another type of energy. Since we are starting the topic energy, we should know all these things just for the meaning of the word. One is tidal energy. Using this, we can produce electricity, hydroelectricity, that is given here. Next, heat. What we are getting, or light, heat or light coming from the sun. So that is solar energy. Next, we are getting movement of air in different velocities, that is wind energy here. Next, waste of fuel, waste of biomass energy, that is represented like that. Then cold geothermal energy, biomass energy, waste to fuel, waste can be converted into fuel. So these are all called renewable energy, the energy whose source never runs out. We need not spend anything for solar energy if we have the materials of initial arrangements. If there is sunlight, then that will be saved in battery through the panels. So like that, whose things which whose source never runs out, they are called renewable energy. So energy here, the definition, energy is the important topic with the scientific, political and social implications. The energy needs of modern society are growing. In science, energy can be studied from many perspectives. Our study of energy begins with the basic energy definition. Already we have seen the ability or the capacity to do work. Energy or units, that is joules. Energy is a scalar quantity. And as we have seen, the mechanical energy is in two forms. One is kinetic energy and another one is potential energy. So mechanical energy is equal to kinetic energy plus potential energy. So mechanical energy of a system is the sum of the kinetic and potential energy. Potential energy is the energy stored by an object due to its position. Kinetic energy is defined as the energy possessed by an object due to its motion. We have seen some other things in the previous slides, so I don't want to take much of your time here. So we can simply see what is kinetic, what is potential energy here. What is heat? Next topic. Heat is energy transferred between bodies in thermal contact. We can feel the heat, that may be the temperature. Different temperature will give different amount of heat. Heat moves from higher energy to lower energy. If we place our hand in a hot source mistakenly, the energy will transform to our heat, which we cannot hold. When we place our hand on ice cube, that the energy will be taken from our hand to the ice cube. When we keep some ice cubes in our hand, even in AC room, that will start melting. It is because of the ice cubes are lower in temperature and they are taking energy from our hands to convert into liquid state, from solid state ice water into liquid state. Heat moves from high energy to lower energy. When something feels hot, it is adding energy to you. When something feels cold, it is taking energy from you. If we hold ice cube, that takes up energy. If we keep ice cube in the atmosphere, it starts melting. Why? It takes up energy from the atmosphere. So it's getting converted into another form which is stable in that temperature. Okay, that is another topic of thermodynamics that we will discuss later. So here, method of heat exchange depends on the materials involved. So method of heat exchange depends on the material involved and also temperature involved. Heat is transferred until objects reach thermal equilibrium, same temperature. So when we keep our hand with the ice or when we hold some ice cubes, till it reaches its temperature, or till my hand reaches its temperature, it works until objects reach thermal equilibrium. Next, what is the unit of heat? SI unit is joule, J, which is equal to Newton meter. J is equal to Newton meter. We already seen this. 1 Newton meter is equal to 1 joule, that is the unit conversion factor. Historically, heat was measured in terms of ability to rise temperature of water. Okay. Then the calorie amount of heat needed to raise the temperature of 1 gram of water by 1 degree Celsius. That is what calorie measured in that manner. In industry, the British thermal unit BTU is still used. Amount of heat needed to raise temperature of 1 pound of water by 1 degree Fahrenheit. Okay, this is what called the unit of British thermal unit BTU. Then change in energy, delta E is equal to Q plus W. And we already seen this E formula only. Then what are all the things? Delta E is equal to change in internal energy of the system. What is Q? Q is equal to heat flowing into or out of the system. Q will be positive if energy is leaving to the surrounding. If energy is lost, Q gets negative symbol. If energy is lost to the surrounding, Q will be minus. If the system is getting energy entering from the surroundings, it is plus Q. W is equal to work done by or on the system. W is the work done. It is also the possibility of two things. One is work done by the system or work done on the system. Minus W if work is done by the system on the surroundings. Plus W if work is done on the system by the surroundings. So delta E is equal to change in energy, and that is equal to Q plus W here what we have.